Okay, now we are at the position to find the positions of three planes relative to each other. So let's say given three planes, so we have this one, a1 times x, b1 times y, c1 times z, d1 equals 0, a2 times x, b2 times y, c2 times z, d2 equals 0, and a3 times x, b3 times y, c3 times z, plus d3 equals 0. So we have three planes. So actually we have these linear equations: a1 times x, b1 times y, c1 times z equals negative d1. So other same, a2 times x, b2 times y, c2 times z equals negative d2, and a3 times x, b3 times y, c3 times z equals negative this linear system. So to find the positions of these three planes, actually we need to solve these equations. So the position of these three planes are related to the solution of this linear system. So if there is, okay, so to solve this equation we need to calculate this determinant, right? Let's say our determinant this triangle. So you have this one, a1, b1, c1, a2, b2, c2, a3, b3, c3. So because this is a non-homogeneous equation, so if this is not 0, then there is unique solution, so maybe I should, there is unique solution. So geometrically three planes intersect each other at one point. So there is only one intersection point. So if these coefficient determinant are not 0, so you have this one, right? Okay, let me try here. So I can put in this way. So the third one is this. Okay, let me correct here. Okay, so these are our intersection point. Okay, there is only one intersection point. So let's say this case 1. Case 1. Now case 2, so if there is no unique solution, but there is more than one solution. So you remember, if the linear system has more than one solution, it means it depends on the parameter. So there is only 1, 2, or 3 parameters. So actually you have infinity solution. So if you have 2 parameters, it means you have infinity 2 square solution. If you have 3, so it means infinity to 3 solution. But actually, every time you have infinity solution. Even 2 or 3, even 1 parameter or 2 parameter, doesn't matter. Okay, so case 2. If this is the, let's say, A1, B1, C1, A2, B2, C2, A3, B3, C3. So if this is 0, so the system does not have unique solution. So it means more than one solution. So depends on the parameter, let me say. Depends on the parameter. Parameters. So geometrically, this says these 3 planes intersect each other along a line. So in this case you have this one. Let's say this one okay, you have three planes like this one, and then you have this line, this like the book, okay, page of the books in the site. Let's say this case 2. Okay, so if there is one solution, unique solution, these 3 planes intersect each other only one point. If there is more than one solution, so it means if it is depend on the parameter, then there is line intersecting these 3 planes. So if there is no solution, this is the remaining part. Let's say case 3. Case 3. If there is no solution, so if there is no solution, but if you have this one, A1, A2 equals B1, B2, and C1, C2. And A1 or A3, B1 or B3, and C1 or C3. C1 or C3. So in this case, three planes are parallel to each other. So you have this one, right? No, they parallel to each other. And the B, another case, if there is no solution, two planes are parallel, and the third one intersect these two planes along two lines which are parallel to each other. Okay, this is another case. So in this case, we have this one. Okay, let me put here. These are the two parallel. And then the third one behave like this one. Okay, so when we say that these two lines are parallel, so it means this one, these two. So how to figure out this one? When you solve the equation, when you see the planes, you need to check the parallelity, two of them, and if the third one also is parallel, so there is no problem. But otherwise, if two of them are parallel, it means the third one cutting these two planes according to two lines. And the case 3, subsection C, so three planes have two intersection lines which are parallel to each other. So in this case we have this one. Okay, let me draw here. So you have this one. And this one. Okay. Okay, now let me give you examples. The first one. Find the position of the planes. So our planes are this one. 2 times x minus y plus z plus 1 equals 0, x plus y plus 2 times z plus 2 equals 0, and 3 times x plus 2 times y minus z plus 2 equals 0. So we have three planes. So we are checking the position of these three planes relative to each other. So like I said in the explanation, first let me write this linear equation. 2 times x minus y plus z equals -1, and x plus y plus 2 times z equals -2, and 3 times x plus 2 times y minus z equals -2. So let me check this determinant. So 2, -1, 1, 1, 1, 2, 3, 2, -1. So if you find this determinant, so the first one, -1, -4, -5. And here you have 1 times, I am here now, -1, -6, -7. And now I am here, so it will be positive again. 2 minus 3, -1. So you have -18, which is not 0. So there is unique solution. So if there is a unique solution, it means these three planes intersect each other only one point. So how to find this point or solution? You can use different methods. So maybe because we already calculated this determinant, we can use the Kramer rules. So you have this one. X will be negative 1, negative 1, 1, negative 2, 1, 2, negative 2, 2, negative 1 over negative 18. Y becomes, so 2, 1, 3, negative 1, negative 2, negative 2, 1, 2, negative 1 over negative 18. And Z becomes 2, 1, 3, negative 1, 1, 2, negative 1, negative 2, negative 2 over negative 8. 80. So X becomes, so let me calculate. You have negative 1 times here, negative 1, negative 4, negative 5. And here you have 1 times, I am here now, 2 plus 2, 4. No, 2 plus 4 will be 6, right? This one, 6. And the last part, negative 4 plus 2, negative 2, or negative 80. So it becomes 5 plus 6, 11, minus 2, 9. So it will be negative 1 half. So similarly, you can find y as negative 1 over 2, and z also you can find negative 1 over 2. So the intersection point negative 1 over half, negative 1 half, negative 1 half. Okay, this is the plane. You see the intersection point. So let me write the intersection point also. Okay. You see, this is the intersection point. 3 planes, unique solution, and one unique intersection point. Find the positions of the planes. So our planes in this case, x minus y plus z plus 1 equals 0, negative 3 times x plus 2 times y minus z minus 2 equals 0, and x minus 2 times y plus 3 times z plus 5 equals 0. Okay, again let me find these coefficients. Determinant 1 minus 1 1, so negative 3 2 negative 1 1 negative 2 3. So you have 1 times here 6 plus 6 minus 2 will be 4, and here you have, because it is negative, will be positive now, negative 9 plus 1, so negative 8, and here 6 minus 2 will be 4. So no unique solution. So it means there is no unique intersection point. Now I will use elementary row operations to find these solutions. So let me write 1, negative 1, 1, negative 1, negative 3, 2, negative 1, 2, and 1, negative 2, 3, negative 5 equals. So first, instead of row 2, 3 times row 1 plus row 2. And instead of the row 3, I will write row 1 minus row 3. So if you do this one, 1, negative 1, 1, negative 1, 0, negative 3 plus 2, negative 1, negative 3 plus negative 1, negative 4, 3 plus 2, 5. And here 0, row 1 minus row 3, so this 1, this negative 2, and negative 1, negative 5, so negative 4. So this will be 2, right? This one. Because you have 3 plus, so will be 2. Negative 3 plus 2, this will be, this one is also this one. Negative 3 plus 2, negative 1. So now I am going this side. Instead of row 3, I will write row 2 plus row 3. So then you have this one. 1, negative 1, 1, negative 1, 0, negative 1, 2, negative 1. So here 0, 0, 0, negative 5. Now if you write the equation again, you have this one. X minus y plus z equals negative 1. negative y plus 2 times z equals negative 1, and 0 equals negative 5. So no solution. No unique solution, no solution at all. So then we need to check the parallelity. They may be parallel, 3 of them or 2 of them. So let me bring these planes here. So let me write here. Now let me check the parallelity. 1 over negative 3 is equal negative 1 over 2, which is not 1 over negative 1. So these two are not parallel. So let me check the other parts. So 1 over 1 equals negative 1 over negative 2. 1 over 3. Okay, no parallelity. So there is no intersection point, there is no intersection line, so also there are no parallelity at all. So these 3 planes have 2 intersection line. Which are parallel to each other. So we don't need to find the intersection line. Okay, just the position. Okay, let me put this. Okay, yeah, this is the case. And let me give one more example, this one. Again, check the position of the planes two times x plus 6 times y minus 10 times z minus 4 equals 0, negative x minus 3 times y plus 5 times z minus 6 equals 0, and 3 times x minus 4 times y plus 8 times z equals 0. So now, if you look at the determinant, you have 2, 6, negative 10, negative 1, negative 3, 5, and 3 minus 4, 8. So you see this 0. Why? Because if you look at the first two rows, you can find the first one by multiplying the second row by negative 2, right? So that's why 0, 0. So also it tells you have 2 over negative 1 equals 6 over negative 3 equals negative 10 over 5. So these two are parallel. There is no solution, but these two planes are parallel. The third one, so let's say this P1, P2, P3. So P1 and P3, P2 are parallel. And the third one, and P3, intersects these planes along two lines. Okay, maybe I should yeah, this is the case. Okay. So you see the yellow one, you have one line here, the other line here, other parts here, okay? So this is the case.